Alright, so these slides are taken from CS 230 Stanford and they were prepared by deeplearning.ai. So we were talking about face recognition here. Okay. So what is Siamese network? You compute, so basically the goal of this was to compute the encoding of a face. In this case, I mean encoding of an image in general, but in this case encoding of a face. So it will output maybe a 128 cross 1 vector. Okay. And now instead of machine, instead of looking at the face, so a machine represents this particular face with this particular vector. Okay. And this notion is not this notion is not used just here, we will see in text, it is everywhere. Okay. So an image is represented by a vector. If you go to NLP, words and tokens represented by vectors again. Okay. We talked about this, we computed the difference between two faces, and we were talking about the loss function. So why this loss function again? See, this quantity is same as what we had written before here. Okay. So we understand this from previous class. Now this will be greater than 0 if these separations will not be enough. So if they are not enough and you have positive and negative examples with compared to anchor, then in that case you need to widen this gap. Since the gap is not wide, you need to widen it. That means there is a non-zero error on that. So you take that part. If this is negative, then you already have the separation that you wanted, right? So for example, if this is 0.5, if this is 0.8, and let's say if your alpha is 0.2, so 0.5 minus 0.8 gives you 0.3, this gives you minus 0.1, right? Minus 0.1 is, so basically if your alpha is 0.2, this means you want separation of negative 0.2 here, right? Which is already there because you have separation of 0.3 there. Okay. So 0.5 minus 0.8 is minus 0.3, which is greater than, sorry, which is smaller than minus 0.2. So this is fine. In this case, what will be my loss? In this case, what will be my loss? 0, because minus 1 comma 0, max of that will be 0. So I am doing already good on this particular example. Other way around, if I have 0.5 and let's say 0.55, in that case 0.5 minus 0.5, that gives me 0.05. 0.05 is not good enough as separation. I required at least minus 0.2. So I need to improve this separation, and hence in this case my loss for this example would be, which is, okay, and you keep on doing this for all the examples. What will you finally do? So M has always represented the number of training examples, and you just sum over them. Okay. Now we come to training. So we already discussed this. During training, if A, P, N are chosen randomly, then this is easily satisfied. You have to still explain this to me. I think this was our last slide yesterday. Yes. So what argument we were talking about in this case? During training, if A, P, N are chosen randomly, then this is easily satisfied. Why so? The number will? Right? No. So why will this be easily satisfied? Because most likely you will have two different faces that look very different. Okay? That's the general case. You won't have two faces looking similar in general. So the case that you will have more often is two faces are really different. Okay? But they are bad examples to train on. Why? If you want to make a really good machine learning algorithm, in that case you will have to give it the hard examples, because see, if you are able to separate just those faces which are easily separable, fine, that's a good job, right? So that's already good thing to do. But in order to improve the performance of our algorithm, we need to do something more. So choosing randomly is just not enough. It works, it is good, nothing wrong about it, it's good, right? But if you do this thing, then it really improves the accuracy of the, yes, question? Okay, then it really improves the performance of the model. Now choose triplets that are hard to train on. And what do we mean by hard to train on? Those examples for which this value is roughly same as this one. And why are they important? I mean, I am asking this question in terms of the loss function. What impact will they have on loss function? Both these kind of examples. So what will be value of my loss if I choose this versus if I choose only this? What will be my loss value if I choose almost all the examples randomly, let's say? Loss will be very low. Why? Loss will be very low because this equation will be satisfied most of the times. So I will be choosing max of negative comma 0, that will give me 0. So my loss will be not very high from 0. Okay, whereas what will this guy do? You are by hand picking those examples that are having this part as positive. So if this part is positive, you take some of them, they will add up to positive. So your loss in this case will be higher compared to this one, right? So you have got something nice to train on. Questions here? Okay. Now, training set using triplet loss. So what is happening here now? Can you help me figure out? So anchor, positive, negative. That means this image is same as that of the anchor, so of the same person, but this particular person is different, and so on. Okay. So which are hard examples? To me, I find this hard, right? But I don't find this one really hard. Okay. Is this hard? Not sure, but I won't call it hard, right? But this one, They look similar, very similar, just a mirror image, right? All right. So face verification and binary classification. So we are done with what we were doing before. So we have done with triplet loss. Now we come to face verification and binary classification. What is going on here? This is a different approach. The previous approach is done. You have trained this using this objective that we saw, maximum of that, and then train and you are done. Okay. Now what happens in this case? Or can you think of something else for binary classification and face verification? This is well within our boundaries we can think of. So my question is the following. Given two faces, you have to tell me whether they are the same or not, whether they are of the same person or not. Is this a binary classification problem? Yes. So no matter what I do in between, how should my output layer look like? Single neuron, right? It's a binary classification problem. So I will have a single neuron there. Now you are supposed to do just classification. How do you do that? See, forget everything that we have done until now. Go to maybe first 5 classes. Go to maybe first 5 classes with a little bit knowledge of convolutions and you will get there. There is nothing new, nothing special in this slide. This you should be able to think of on your own. In fact, it is written here. Now if you can see, y hat equal to whatever. Right, but MNIST data is multi-classification. This is just single classification. Right, so whatever you were doing for logistic regression, this is logistic regression, right? So yk equal to 1 to 128. 128 features you have here, okay? So not 128 examples, you have 128 size vectors here. If this were 256, this will become 256. So 128 features here, 128 features here. F of xik minus f of x. So take this one and take this one. So first minus first, second minus second. How many features will you get from these two vectors? So this is your fx1. This is your fx2, you take basically this minus this, right? Basically this minus this, whatever comes, and you are supposed to take mod element wise, okay? So this element minus this element, take their difference, take their modulus, okay? So it's not exactly difference, it's basically modulus of this. Once you have modulus of this, so basically this vector will again be a 128 size vector. Now you have a logistic regression problem. All these guys will be x1 to x128. And how were we doing logistic regression? wx plus b. What is w? If this is my only, what is w? So w1 all the way until w128, x1 all the way until x128 plus b. Okay, this is your y hat if you take sigma of it. So guys, whatever we have done in this course until now, if you see, our inputs remain the same. There are very few ways in which you can treat the output. Everything in between you can do whatever, but all the outputs they are pretty standard, right? Any questions here? And you could do something else as well. So for example, you can take chi square. So instead of taking just this, you can take chi square differences. Okay. So if you just don't like the plain differences, you can do some other function of this entity and still make 128 features, or do whatever you want and choose whichever one works the best. Any questions here? Okay. So tell me one thing, if you are making a database, for example here, attendance of all JKLU employees, if you are making this database, would you store a image of all the persons registered in the database, or you may also choose to store their, what were these, what did we call them? Encoding, right? Encoding. So will you like to store the image itself or the encoding only? What would you prefer? Image? Okay, what will be the benefit of that? इमेज स्टोर करोगे तो कम डेटा स्टोर करना पड़ा तुमको. राइट. Face recognition algorithm. So you know, this is a little bit digression from what we are doing, but is an application of face recognition algorithm. So Indian cyber security team, certain and right. So what happens, a lot of people, particularly fraudsters, what they do is they get Aadhaar card issued on multiple names. Rajasthan, Haryana, Maharashtra, West Bengal, Bihar, okay. So, and they look different, the same face, right, they will wear sari and will become female, change name accordingly, the same thing, you put a turban and so on. So, change your faces in different manners. What police was able to do was, they were able to figure out, so they were of the orders of hundreds, that these 100 Aadhaar cards actually belong to the same person. And how could they do it? Because of face recognition. So चश्मा लगाने से face recognition नहीं बिगड़ता है, बिगड़ रहा है ना तो उसको फेंक दो, right? Even if you put beard and all these things, face recognitions are very much robust to that as well. So hundreds of images of the same person trying to deceive authorities, and then basically their idea is to get issued different SIM cards on different names, right? And those people don't even exist. Get an account number, do frauds, transfer money there, they belong to you, and then finally transfer it to some bank account abroad. More questions here? That's my question. Now, you can store images if you have a small database like JKLU. Okay? What you will still have, your machine, each time it recognizes a face, it will still go through this. Because you are not storing this, since you are storing this, each time you want to match a person in your database, you will go through this whole process. So that machine needs to be computationally little bit more efficient compared to if you store just this. So if you store just this, right, you will have to go through this only for the live person and not for the rest of the part. Okay, and now if this difference, so whatever, same person or not, do the rest of the computations, but at least storage part you could do in this term as well. Sorry? What you are saying is coming from this. So in your database, will you store multiple images of the person? That's a good question. But this was for the training time. For the test time, you don't need a database 10 times larger than what you actually are looking for. Okay. So ideally what will happen once you are done with this training, for all these, so assuming that every person has 10 images. So for all those 10 images, encoding will be, so the difference of encoding will be close to 0. Okay. That would be the result of the training process. Yes, more questions? Huh. Yes. Yes. So there are so many wrong things with that. Even if you put something here now, it will still recognize you. So
depends on how you are trained your model.
So
no, I'm saying last, not this one, the last biometric. So maybe during registration I was smiling. So if someday I come and stand like very dull face, it will not recognize me. Unless I smile, it will
Because
not.
it makes a big difference in sad patients.
But still my features are still
right, so that's why we changed now. Because see, you were smiling, so it's good. What happened if I was dull that day? So, these two papers, if so FaceNet is certainly from Facebook. DeepFace, एक बार देख लो DeepFace कौन, I think Facebook again.
जैसे 4 इमेजेस पे अपना जो मॉडल है वो ट्रेंड है, मेरे पास में 4 में से एक जना आया, एक टेस्ट है.
So you have all these 4 in database?
अब मैं कोई चेक करना है कि ये जो पर्सन है ये डेटाबेस में है क्या?
जो पर्सन है ये डेटाबेस में है क्या?
लाइक उसकी जो वो फेस रिकॉग्निशन हो रहा है.
ओके, हाँ हाँ.
तो अब जो पर्सन टेस्ट टाइम का है उसका उन सबसे जो एनकोडिंग है उनसे डिस्टेंस निकाल के फिर मैट्रिक करने के कैसे होगा?
This one. Get an input of image, output ID if the image is any of the k persons or not recognized. बताओ कैसे करेंगे? Is this a linear search? So can you really give up searching on this? Search you must still do, right? So you have n different encodings, you have new one, you want to match which one, you have to still do that searching operation. You can make that searching more efficient, I don't know how, but you can't really give up on searching. Okay. Yes, and you can make it more efficient. For example, if the first thing is negative, then I compare it with only those guys whose first thing is negative. So that way you might keep on reducing this sample space very fast, but I don't exactly know how do they optimize. There must be some optimizations. Okay, so we are done with face recognition. So in this case, so guys, one more thing. This approach is totally different from the triplet loss approach. This approach is simply binary classification. These two faces are same or not, and that's it. So finally, what you will have when you are preparing your data set, you have these two images, 1 if they are the same, 0 if they are not. Build a big data set, train your model, and then you are done. Okay. So neural style transfer I won't do, those things are of, I mean it's a good academic thing to do, but I think we have enough of computer vision now. This might still, but we have talked about a little bit in, so pick a unit in layer 1, we have already talked about this. So what are these layers actually learning? So for example, layer 1 will have something like this. So yes, bigger one. So what is layer 1 learning? See, yes. So initial layers. See, if you take this whole thing from left to right, your left is, what is this representation? Complete pixel wise. You give the system pixel by pixel details of this image. On the right hand side, you have output that human wants. For example, this face is of a particular person, or there is a face in this image, right? So all these layers collectively they will just build, right? So this guy, then this guy, and so on. So we come back here. So initially, so why do you need so many convolution layers, right? At least you need 15-20. I mean roughly, not a rule of thumb. Now layer 1 is this guy. It learns whatever it can learn from raw pixels, right? So from raw pixels, what you can learn are simple structures like lines, colors of different shapes, lines at different angles, right? So all you can do from raw pixels is just this. Now you take this one. So now your inputs are not just raw pixels anymore, they are straight lines and different simple structures. You can now use those structures to build even more complex ones, and you keep on doing this until you reach to the final layer where you start recognizing the whole object itself. So until you reach close towards the representation of the whole image itself, okay. And that's it. So I think this is what I had to say about so I think this is all I had to say about computer vision. I would really like to do UNet, but maybe not today. So second class kare? So I think I am done with computer vision. UNet is left. If you want, we can do UNet, but since वो एग्जाम में नहीं आएगा, no point. हाँ, यहाँ तक आएगा. बट आज तो क्या किया है, कल वाला ही तो रिपीट किया है यार. मैं यूनिट करने की सोच रहा था आज, बट because that's the only thing left in computer vision. So 2 papers I would like to do. One is UNet, another is segment anything from meta. Okay, but I am not sure. एक बार computer vision छोड़ेंगे तो फिर वो time नहीं आएगा अपने पास. Anyway, done for today. So